Hey guys, it's Zong here. Today, we're going to be tackling vectors. Um, I wanted to do a video about this because, first of all, I wanted to do one on heart-shaped graphs because of Valentine's Day, but I couldn't understand any of the graphs to make a heart, some trigonometric stuff, and blah blah blah. And also because this question was one of the only ones I failed on in math class, like actual school math class, because I never learned vectors before. So I was really sad about that. Um, I'm worried about getting a B in math because of this. But anyway, I thought it'd be nice if we learned about vectors today, because not many people know about them. They don't show up in competition math. So without further ado, I'll explain the question. So you have a rope, and here are two pegs, wood pegs, I guess, and this is a rope, and it's held on down here, tied down here, with a weight of 5,000 pounds going downwards. So you want to find the tension on both this and this. So the tension, I'm going to note as A and B, is a force in pounds. It's not the length; it's the tension or the force being exerted on A and B. So just to explain vectors for a bit, a vector is defined by having a direction and a magnitude, and the magnitude is what, in this case, usually it'd be what the length is, but in this case we're dealing with forces, and usually vectors are used with forces, and when used with forces the magnitude is just the amount of pounds exerted. And to note direction with a vector, okay, usually vectors are identified like this: A, B, and A is the, if you were to put this with its tail, I mean its end, at the origin, A and B would be where the head would be. So this would be A, B. So this is what we mean. And usually to denote the length of the direction of a vector, you'd put it in the form of a unit vector. So we always denote a vector by moving it to the origin. So this is 0, 0, and AB. And the direction of a vector is usually noted by a unit vector. And a unit vector is just a vector with magnitude of 1. And a magnitude, of course, is just the length of the vector. I know we said forces, but like when you're in coordinate world and you're putting vectors down a coordinate plane, it just, usually it's easier to see it by length. So length is just magnitude of 1. So it's length of 1. And usually the coordinates will be something like, since you can see there's a unit circle here, right? And the end of the vector has to lie on the unit circle. So usually the coordinate of that end on the unit circle will always be cosine. If this is the angle, or if this is the angle, or whatever, it's usually denoted in some form by cosine theta and sine theta, because of course cosine squared theta plus sine squared theta equals 1. And this is the magnitude. I mean, it's the x coordinate squared plus the sine coordinate squared. In Pythagorean's theorem, you just get 1. And these are usually going to be the notation to denote the direction of a vector. And then how do we implement the magnitude of that? The magnitude of a vector will usually be multiplied by this. And the reason it's multiplied by this is because if you have the direction of a vector but its length is 1, multiplying this by both coordinates will just elong the vector to a length m, like so. So if you really want to find the exact coordinates of a vector, it's usually going to be in this notation. This is going to be the direction of the vector, because the direction of the vector is just determined by the unit circle. And the reason we only want it to have a magnitude of 1, cosine squared theta plus sine squared theta is 1. The reason we want it to lie on the unit circle is because when we multiply it by the magnitude, then the length is just the magnitude. Because the length is just 1 times the magnitude. So that's why you just want it to be in this form. So if we know the direction of the vector through this form and the magnitude well, we don't know the magnitude yet, but we can get the magnitude through some algebra. And I want you to remember that I know that I didn't get this at first either. It's really a lot to take in. But a really important thing to note is that cosine, this thing is the horizontal, the horizontal factor, and this is the vertical factor. And I'll show you what that means later. Basically, this is the thing we want to note. We want to note on vertical force, and this is what we want to note on horizontal force when we put them together. And I'll talk about that later when we're doing this problem. So, okay, let's look at the problem. So, I already put the angles down for you, but usually this problem wouldn't have the angles. But the angles is just since this angle, this is 24. This angle would just be tangent to the -1. Oh shit, that's 7.38 equals tangent of 24 over 10. And likewise, this would just be the tangent, negative tangent, the tangent -1 of 24 over 20. And the angles are right here. Alright. And, okay, so A and B is the force, right? The tension of the thing. And we want to find out basically the magnitude of A and B. And we want to note something. Remember what I said about vertical factor. Basically, this 5,000 thing is going downwards. And it's going downwards with a force of negative 5,000 because it's going down. That doesn't really matter as long as you... Yeah, but it's negative 5,000. Let me just erase this stuff to save space. I should really find a more efficient way of doing this. Or maybe this thing. You got that? Yeah, I need some space. So, this is going down by direction of negative 5,000, right? And it's going down in a direct vertical direction. And this vertical direction will be the sum of the y coordinates or sines of these multiplied by their magnitudes. And I'll explain that later. But okay, and this horizontal. Oh, whoops. Okay, what is the force being exerted in the horizontal direction? You may think, oh, there's got to be some force, but really it's 0 pounds because both these strings, it's not moving to the right or to the left. The strings aren't rotating. There's no difference in force. The amount they pull is going to be 0 because it's going to be evenly distributed. So horizontal factor is 0, and the vertical factor is negative 5,000. Don't quote me on the horizontal and vertical factor because I sort of made those up. Yeah, okay. So let's find the directions of these. So the direction of this vector would be, I believe it would be, so cosine. Okay, so let's pretend this is the coordinate plane. Since this line right here, since it's going this way, cosine will just be positive. So it's going to be cosine 67.38. However, sine will be negative because it's negative 24 and it's going downwards. And you want to keep that in note because sines do matter. So it'd be sine negative 67. Yeah, 0.38. Yeah. And it's negative because it's in the fourth quadrant. Hopefully you came into this video knowing a bit of basic trigonometry because vectors are vectors are mainly based off trigonometry. So, and then what's the direction of this? If this is the origin, then this would be since it's in the third quadrant, both are negative, I think. So cosine negative 50.19 sine negative 50.19. And what do we want to do? We want to multiply these by the magnitudes to get the vectors, right? So if we multiply it by A and B, these are what gives us our vectors. Now, to calculate what the horizontal force, the force that's being exerted this way, is denoted by the horizontal factor. So cosine 67.38 times A, which is the magnitude, the the total tension on this. What's being exerted horizontally? Not this way, actually this way. Well, it doesn't really matter the direction, but what's being exerted horizontally? What force is it's giving is the horizontal factor. Because think about it, if this was a unit vector, cosine 67.38 would denote how far left or right this would be. And multiplying that by the force, it would just give us how much force is being exerted left or right. And similarly, sine, this is the vertical factor. So since sine on the unit circle denotes how up and down we will be, multiplying this by the tension on the string will denote how much force is being exerted vertically. And this is important because think about it. We just established that the horizontal force of these two the horizontal force that these two strings exert is 0. So we know that they're 0, then we just know that the sum plus cosine negative 50.19 b equals 0. And that's one equation already. We have a solid equation right there. Because remember, cosine is how far left or right it will be, so multiplying by the magnitude will just determine how much horizontal force is exerted. I know it's hard to understand, but hopefully just remember it for the future. Yeah, sorry, I'm not a very good explainer. So similarly, we established that in the vertical, their total vertical forces amount to negative 5,000 pounds. So sine negative 67.38 plus sine negative 9 equals negative 5,000. A and B. Sorry, I forgot that. A and B multiplied by these magnitudes. And remember, this is really just this thing right here is really just the x coordinate of the vector. This thing, I don't know how to draw arrows. This thing is really just the x coordinate of this A vector. And the x, what's funny is that the x coordinate actually determines the amount of horizontal force the vector does. And this is the x coordinate of this vector. This vector right here, and this determines how much horizontal force it does. So just keep that in mind, that the x coordinates of vectors keep track of how much horizontal force there is, and similarly for the y coordinates. So we have a system of equations. Maybe we can finally solve for the tensions. They're right here, and I'll just write out. I'll just simplify it for you. It will be 0.3846a minus 0.6402b equals 0, and 0.923a plus 0.768b equals minus equals negative 5,000. Sorry. You can solve this, and I did it by hand, so I'm not sure about its accuracy, but I think these are the answers. So A is 3612.5 pounds if you solve it, and B equals 270 pounds. And that's how you use vectors to solve for tension. And it's really interesting because vectors are really the only concrete method, other than like hard trigonometry, to easily solve for forces instead of lengths and stuff like that we usually find in geometry. And they can be complicated because it's hard to move from a coordinate world to a vector world where there are different rules and vectors have different properties and stuff like that. Especially the part where length is converted into force. That part was something I really didn't get at first, but eventually after doing a lot of problems I got it. So if you're confused, I know vectors are confusing, then just go through this video, rewatch it, try to understand it. Hopefully you can see the patterns. Cosine is just horizontal force, and sine is vertical force multiplied by magnitude. Yeah. So if you didn't get anything, it's not your fault. I'm a bad teacher. So see you next week then. The solution. So the 11 lily pads labeled in a row 0 through 10. Frog is sitting on pad 1, and the frog is on pad n. 0 is less than n is less. Yeah. Okay. So how do we go about this? Usually when you face these type of probability problems with like probability going forward is this.